within that, you have, first of all, built-in safety capacity, which is fine for the integrator to include. But what is here different is that it might mean that within this built-in safety capacity, so what is the available energy might be corresponding naturally to with some suppliers to 95% SOC, and with others to the full 100% SOC.
So where it all starts, and I've seen that many of you have actually think about costs, which is certainly a very important topic, besides any other additional ones that I'll be talking about later on. For costs, and which is not let's say not a surprise for many of the energy storage enthusiasts. Energy storage systems have been benefiting from fluctuating prices over the years that have been growing down quite rapidly and quite an extensive way.
Starting with factory audit and inspection rights, which are, for me, a no-brainer, but as mentioned on the previous slide, easier to include it in the contract than trying to negotiate this at the last minute with the supplier during your FAT. And so it should be a no-brainer. Like today, the practice is usually to agree with it. I will be extra careful if you have any need for ESG and or supply chain mapping traceability audits.
The feasibility study. So as I've said before, the feasibility study for it is divided into two main activities. The first one is about the screening of the site itself, where you're planning to put your battery. So like I've said, so the available surface is very important. One of the elements that have been, let's say, evolving in quite a positive sense is solution formats, which is coming up in the next slide. So solutions have been getting denser and denser, so you can put more, let's say, megawatt hours in a more restricted space.
And welcome to this new Sinovoltaics webinar. I am delighted to host Naim El-Chami today from Clean Horizon. And the webinar will be about optimizing cost and compliance, navigating BESS procurement in a shifting market. I am Arthur Claire, Director of Technology at Sinovoltaics, and I will be introducing you to this webinar. Welcome. So, as you may know, in Sinovoltaics webinar, the structure is always the same. We have around 45 minutes webinar, as well as 15 minutes Q&A session. So you can use the chat on the right of your screen to type any question at any time. We will answer them at the end of the webinar. But please ask questions to Naim and I. So about Naim. Naim El-Chami is a lead consultant of Clean Horizon. He's a Central Supélec, Université Paris-Saclay, and St. Joseph University graduate. His expertise covers the techno-economic assessment of energy storage projects and the management of gigawatt-hour scale procurement. He leads knowledge management activities around several topics, such as long duration and novel energy storage technologies, as well as fire safety of lithium-ion battery systems. Welcome, Naim. So myself, Arthur Claire, Director of Technology at Sinovoltaics. At Sinovoltaics, we support IPPs and EPCs in deploying high-quality, reliable solar module and energy storage projects. I personally manage our energy storage practice, and I'm delighted to have all of you here today. All right, so let's go. I will start first with a few points about BESS contracts, and then Naim will cover his presentation. So first of all, just a bit of information about Sinovoltaics. We are what you could call an inspection company, but we are data-driven inspectors. Our clients are utilities, IPPs, EPCs, project developers, and we help them to reduce their supply chain risk. By supply chain risk, we mean quality. By performing factory audits, we go to the factories, we do inspection of PV modules and other components, of course, as BESS, inverters, cables, trackers, transformers. And we really go beyond sampling with innovative solution like BESS for energy storage and Selma for PV modules. So that's the first supply chain risk is about quality. Second supply chain risk is about making your supply chain more transparent. So we have traceability and ESG dedicated services like ESG audits, supply chain mapping audits at the factories, as well as helping our US clients to import and to provide traceability evidence to import modules of BSS into the US. So to start with, we'll do a simple poll. This I would like to understand what the audience is today. And so what stage are you currently in with your BSS projects? What kind of experience do you have? Is it that you're just considering BSS projects, you have no experience, you are currently working on your first project? Is it that you already have a first project in operation, or you are, I would say, a seasoned BSS developer and you have several projects in operation? So I see already people starting to answer that question. Thanks a lot. And let's see what we have here. So it looks like we have mostly people with, I would say, no or small experience on BSS, which is quite interesting. So I guess the topic of the webinar is really perfect for you. Okay, interesting. Second question we have for you, and after we will really kickstart the webinar, is which factor influence your choice of BSS provider? Is it mostly the cost solution, BSS performance, supplier trustworthiness, or warranties? I'm really glad we have really active people in the audience that already start answering the questions. That's really great to see. Thank you, guys. Okay, so it looks like it's a short win by BSS performance over cost. It's quite interesting to see. So let's talk about it. All right. So my presentation, I will focus about BSS procurement contracts basics. So let's jump into it. So contracts are usually designed around two key topics. First one being commercial and the other one technical. So by commercial, I call it the obvious, but of course price. It was one of the most influencing factor of BSS, just like for any financial transaction. So of course, price is important, as well as Incoterms, and especially defining the time where the BSS ownership is transferred in terms of insurance, for example, are really key. About the less obvious, I will consider spare parts that I will include in the contract, ensuring and making sure what kind of spare parts do you have access to, if you need to pay anything for it, and yeah, what are the conditions about it? Will it be shipped to you automatically during site commissioning, or after that, after a couple of years, you need to clarify everything that is happening there. Second topic is about support. I think it's extremely key, especially it's true in any case, but especially if you have little or no experience in BSS, is to really understand the support structure of your BSS provider. Does he have any support team in Europe or in the US? Are they able to speak English? Is there any guaranteed answer in time if you have any issue? Those are really key points to really consider, I believe. Next, about the technical side. So again, obvious part is about including user manual specifications of your components in the contract. So not only the BSS, but also the battery pack or battery rack, and also battery cell. And so that way you can also cross-check the different specifications, making sure that it is making sense, and that you can always come back to the battery cell specification if there is any issue down the line. I would add one extra point here, that since we implemented BESS, we start to see some suppliers that are using specifications and telling us that it's kind of a marketing trick. like they are not really respecting their specifications. So really by adding it to the contract is really critical, I believe, making sure that all the specifications are contractual, and I would say will make sure that your supplier will respect them. But the tricky part is about cell degradation. So as you can see here on this graph, of course, you have several parameters that will influence cell degradation. First one being number of cycles, obvious one. Also charge or discharge rate, as well as temperature of operation of the battery cell, and also the depth of discharge of your battery cells. So what I would ask my manufacturer here is to kind of adapt the warranty and the performance specification to my true business case, according to my C rate, to the expected operating temperature. I think is really key, because that way, if there is an issue in 2, 5, or 8 years, you can come back to that table and not trying to do some calculations between the standard warranty, between the standard performance warranty and your business case, which is totally different. It's a nightmare. I've seen clients being in that position, and those are always extremely careful about this. Another point that we see more and more, I think, in the kind of a race of bigger container right now, is that you have specifications of 5 MWh container, sure, but within that you have, first of all, built-in safety capacity, which is fine for the integrator to include. But what is here different is that it might mean that within this built-in safety capacity, so what is the available energy might be corresponding naturally to with some suppliers to 95% SOC, and with others to the full 100% SOC. And same for the lower limit. Do you have available capacity, available energy between 0 or to 100%, or between 90% to 10%. It's really key to clarify that. And within that available energy, you have to be careful about the recommended depth of discharge, because you might have access exactly to 0% to 100% SOC, but if you can actually use only 80% to 20%, it's a totally different story. And so in the end, what you may end up with is that you are buying a 5 MWh BSS, but you are getting a usable 3.5 MWh BSS. So you need to be extra careful. And one easy way to see this is to check again for the performance warranty in your contract. Because if you start buying a 5 MWh BSS and your warranty is starting at 4 MWh at site commissioning, it means there is some trick playing here, like the ones who are seeing on this slide. So I will be extra careful here. And kind of as a more general comment about contracts for BSS or for any components, is that I will be extremely careful about what is not in the contract. So it's fine to trust technical person from your BSS manufacturer, but then I will still include as many information as possible in terms of technical information, spare parts, as we have seen in the contract, to avoid issues 5 years down the line in your project. So yeah, what is not in the contract is not covered. It's kind of a warning sign we are seeing every day at Sinovoltaics, doing factory audits and inspections. And about that, I will focus the later part of my presentation on zooming on BSS contract, quality audit, quality control clauses, starting with factory audit and inspection rights, which are, for me, a no-brainer, but as mentioned on the previous slide, easier to include it in the contract than trying to negotiate this at the last minute with the supplier during your FAT. And so it should be a no-brainer. Like today, the practice is usually to agree with it. I will be extra careful if you have any need for ESG and or supply chain mapping traceability audits, which are more new to the industry. And so you may see some roadblock from the manufacturers about it. But again, try to put it in the contract will make everything clear for everyone. So you should do that. Second point is about the FAT and site commissioning checklist. So you should have clear visibility on how many modules, on how many BSS will be tested, what kind of tests will be performed, will there be any performance test. We had a webinar last week about it, about the shortcuts being taken by manufacturers doing FAT. So if you want more information about it, I strongly recommend that you watch this one. Then ensure raw data access. It's related to our BESS Essential service, but during the FAT, so with BESS Essential, we collect raw data from the BSS generated during the performance test of the FAT. And we are seeing lately some roadblocks from the manufacturers to provide this raw data. And for me, that's a massive red flag, because there is absolutely no reason that will prevent the manufacturer of sharing raw data generated during the FAT, especially considering that you are buying a container worth hundreds of thousands of euros or US dollars. So you should have the right to access this raw data. And again, make it sure by including it in your contract. And last but not least, I will also include the monitoring data that you want to see. What kind of data should be integrated? What kind of data you should have access during site operation, and what is the time frequency? Because sometimes some solutions, they provide really only a small amount of data points, and you want to make sure that it will be the most comprehensive solution for your site operation. So I will be so careful about it. And so all those 4 points are detailed in one of our BESS Essential white paper add-ons. So here you have the QR code. I strongly recommend you to download it if you're interested. So you will have contractual language for each of those 4 clauses. So that's it for my part. If you have any questions, please put them into the chat. I will answer them after Naim's presentation. But in the meantime, I will let Naim take the floor. Thank you.
Perfect. Thank you, Arthur. Thanks for everyone that has been joining us today. So as let's say, as the topic here says, so my own perspective today is to give you an idea about the main challenges and perspectives when it comes to procuring a BESS project, especially with the actual context where the markets keep shifting, either from a, let's say, from a market perspective, especially accessible revenues, as well as the evolution of the cost of these solutions and their formats, as well as how would that also be affecting the procurement strategy if you're considering to develop a battery energy storage project. To start, here's an idea about the agenda itself. So I'll start with a brief introduction about Clean Horizon, what we actually do at this company, before then shifting to the core of this presentation, where I will start by talking about the early on works that need to be done whenever you're considering a project, which is more about the business model and ensuring the economic viability of this project, before delving into the next step, which is the actual procurement and getting the project across the finish line through this exercise. So do not hesitate to send us your questions. As Arthur said, we'll be happy to answer them later on. Now about Clean Horizon. So Clean Horizon is a one-stop shop for energy storage services. We are active in more than 81 countries and are based in Paris. So as of now, we have designed and audited more than 22 gigawatt hours of energy storage projects across the world. And these projects, as I've said, are pretty much in more than 81 countries. Besides that, we have also our own in-house database of projects called the CHESS, in which we are referencing public utility scale projects, which are sized at 1 megawatt hour or above. So on that note, as I've said, we are a one-stop shop. We've been here for more than 15 years now, which some of you might be seeing it in the logo in my background. So in terms of services, we do two main lines of activities. The first one is about market analysis. So under this line of services, we do everything that is related to assessing the viability of energy storage system when it comes to participating in a specific energy market. So we assess the regulatory context, what kind of revenue streams are accessible, and how can this business model be constructed based on different in-house products, such as market forecasts, as well as dispatching models that would actually try to simulate the actual activation of a battery storage system on the different markets in a specific country, locality, or even more on a regional basis. Uh, as for the technical consulting part, so that's where we lead services related more to the what we call the procurement support, where we will be helping project developers and IPPs in their efforts to procure energy storage systems. So it goes all the way from doing the initial feasibility studies, from the design of the solution, drafting of the RFE documentation, and supporting the selection of the optimal, let's say, solution provider. Then shifting to the negotiation of the different contracts, whether it is the actual supply contract or even the maintenance one, all the way down to the actual commissioning phase, where we can also support our clients during the commissioning phase to ensure that all of the required performance tests and best industry practices have been respected on this level. So here in this slide, we're showing things in a more granular way. So as I've said, the first line in this slide mostly covers what we call the market analysis services, which includes this forecasting of energy and ancillary services in different markets across the European continent. Our own product called Cosmos, which is the simulation tool that I will be talking about briefly later on, and also supporting project developers and potential investors in what we call the commercial due diligence to support with the assessment of an energy storage project in the hopes of facilitating an acquisition process or a potential introduction of a new investor in a specific exercise. The technical part is more about, as I've said, the feasibility studies to support the development of a given project, selection of supplier, and support during the commissioning part, as well as I've said, with the commercial due diligence, the technical due diligence, where we also act as an independent party to help assess the technical correctness, if I can say, of a project, all the way from the selection of the supplier to the design of the project itself and its respect of top industry practices and the critical certifications that are needed for a specific geography. Now, about the technical, say, consulting part, as I've said earlier, we at Clean Horizon have designed and audited more than 22 gigawatt hours of projects. This data refers to is updated as of the end of October. So this volume has been increasing quite rapidly to accompany the booming industry, and these values do not cease to keep growing. On that note, perhaps I will just stop with this presentation so that I can get you to the core of the content, which I'm pretty sure that most of you are looking for. Now for the first part, which is about what needs to happen and what are the considerations before you actually start procuring your energy storage system. So where it all starts, and I've seen that many of you have actually think about costs, which is certainly a very important topic besides any other additional ones that I'll be talking about later on. For costs, and which is not let's say not a surprise for many of the energy storage enthusiasts, energy storage systems have been benefiting from fluctuating prices over the years that have been growing down quite rapidly and quite an extensive way, as you can see in this graph. So this decrease has been happening since early 2017s, where we've seen this kind of decrease happening thanks to the adoption of new chemistries, notably lithium iron phosphate LFP solutions, which are less expensive than nickel manganese cobalt thanks to this composition and to the massive production. And then, however, between 2020 and 2022, we've seen an additional hike in these prices due to the supply chain restrictions, as after COVID, demand started to grow quite extensively and surpassed, let's say, the production outputs. However, that didn't last for too long, as since the end of 2022, this sharp decrease has been happening in quite an accelerated way, as the prices as of now are let's say are at an average of $125 per kilowatt hour, and they are not supposed to stop going down anytime soon, as we can expect that by 2030 these prices are will be at reaching $80 per kilowatt hour and even $70 per kilowatt hour by 2035. Now, the thing that I needed to, let's say, to highlight in here, that these prices that you are seeing are for the enclosure, for the, let's say, for the system enclosure itself, which is the DC part of your energy storage system. So they do not include the inverter, nor the transformer, nor any of the, let's say, balance of plant works. So we're only talking in here about the DC unit that includes the battery cells, plus any additional equipment that would help form the entire, let's say, energy storage product on the DC part. Now, um, as I've been saying just before, these prices have been going down quite fast. They have been going down so fast that that even, let's say, across previous let's say provision let's say forecast from our side, an earlier version of this graph had actually expected to reach $130 per kilowatt hour by 2030, which has happened much earlier, so 6 years before that. Uh, Sorry, yeah, exactly. So 6 years before that, which is showing this high dynamic that is being pushed by extensive enhancements of the technology itself, the high competition, as well as the optimization of the manufacturing processes from diverse tier one suppliers, mostly located in China. One final note about this graph is that most of the historical data is based on our experience as owners, engineers, and as well as our discussions with solution providers and public information. The same goes for projected data that's also based on our understanding of the industry, plus projected solution enhancements and the evolution of material raw prices. So that definitely doesn't say that we may never see another price hike such as back in 2021, 2022. But at least for the foreseeable future, things are quite good. We're quite optimistic in the sense that these prices will keep going down. Now, so we've talked about cost. As I've said, it's a very important step before actually deciding to buy a battery is to see whether it is actually viable. So will you be able to generate revenues with this battery, and will you be at least able to recover your investment? So one very important step before actually going to the procurement phase is to simulate the accessible revenue stack and prepare the business model for your project. So here in this slide, I'm just showing you an idea of some of the elements that are very important for you when you're trying to assess your project, but also very important for the financing institutions that you will try to reach out to finance your project, which is very often the case if you're not planning to use your own, let's say, equity funds on a complete basis for your project. So one of the first elements that we try to look at is what we call the revenue stack. So the revenue stack itself is usually the output of two important elements. The first one, which is what we forecast data. So a service that we also propose, so where we try to forecast the different prices on the different accessible revenue streams for energy storage system, whether it's the energy prices or the ancillary service prices. So you get that, and then once that has been done, you need to inject the data in what we call the dispatching model that would try to simulate the actual dispatching of the battery on the different markets to optimize the accessible revenue streams. So once that has been done, you will start by getting an idea about the level of revenues that you should expect on an annual basis over the lifetime of your project. So it could go all the way up to 25 years, which is some of the observations that we see in other geographies in terms of the lifetime of an expected energy storage system and on which the business model needs to be built. So once that has been done, another good perspective of this revenue stack is what we call let's say the waterfall graph, in which you get a clear idea about where, let's say, the main costs are coming for your system. So it's that you have certainly have the cost of the system, the operation and maintenance one, but as well as some grid connection fees and what we call the aggregator or route to market fees that also need to be taken into account. And on the other level, let's say the potential revenues that would try to compensate and ensure project profitability. So one of the main metrics that also very important is the project RRR, sorry, the internal rate of return. That is also a very important metric. One of the, let's say, at least one of the very important metrics that would need to show the viability and the positive investment when it comes to a specific project. So in here, well, I'm not taking much time, but at least when it comes to simulating the dispatching of energy storage system and how at our own, let's say, the Cosmos tool works, the goal here is to take a series of parameters when it comes to the capex of the system and the operational expenditure as well, especially to take account of all the different costs, whether it's a standalone project or a hybrid one, then take account of all of the specific properties of the project, of the energy storage system. Let's say you have the capacity, so the sizing as an overall, the round trip efficiency, as well as the different efficiencies of other component of, let's say, included components within this project, such as transformers, cables, PCSs, etc. Then including the market parameters when it comes to the different thresholds and market conditions, as well as prices, so that the model itself can turn and optimize the dispatching of the different revenue streams and optimize the internal rate of return and the net present value. So I'll stop it right here. So please, if you have any questions, do not hesitate to reach out on the Q&A part or later on if needed. On that note, I'm shifting to the last phase, which is about the real procurement. So we can, at this phase, we will suppose that you have already analyzed your project, you have ensured that it is actually viable, and you have reached the decision to take it further and start procuring your energy storage system. So to do that, you need to have a perspective about the main or the most classic, or what I call here stepping stone, or at least phases when you decide to develop this project. So the very first part is about the feasibility study. So you have ensured, in a sense, the economic viability on paper. Now you need to make sure that it is actually can be developed. Some of the main elements on that note are what we call the site and environmental constraints. So you can certainly not place your project in a zone where you are almost certain that it will be flooded, or place it very close to noise sensitive areas where it will be making too much noise. So on that level, you would either review your investment decision or take account of specific mitigation solutions to limit the impact of such restrictions. Some of the other elements are also very important, You have the access to the grid. So if you cannot access the grid, there's let's say there's no sense of placing energy storage system if you can't charge or discharge it. Again, then there's also the part about the land, what we call the available land and suitability. So let's say that your business model was based on a specific best sizing, but you end up, let's say, observing that the land is either too big or too small. So if it's too big, so you can still put it, but the eventual development expenditure would be just too high because you're leasing a land that's way too big for your needs, and vice versa. So if the land is too small, then your project won't fit, and you will need to adapt the sizing to make it fit. Um, and then you have what we call the permitting. So once you have ensured this feasibility, you will need to start preparing permit documentation, everything going from the construction permits, the grid connection permits, or even the environmental authorization. So depending on the geography, the complexity could be different. So some countries are, let's say, are rather tricky when it comes to developing any storage system. Some others have specific regulations when it comes to placing it next to sensible, let's say, locations, whether it's a forest, an industrial complex, or even next to an urban area. So there's a lot of considerations that would need to be done on that level. Then the third part, so once you have started preparing these elements, if you once you start preparing the permitting, you can in parallel already start working on what we call the uh, the, the drafting of the procurement documentation, which is about preparing and administering what we call so RFP. You have the request for proposals. You also have other variants of it, which are more or less complicated. You have the RFQ, the request for quotations, and on and on. So on this level, and as Arthur said before, and as I will be detailing later on, the documentation is very important, and the details are also of what you say and not say inside these documents is also very important. But in general, this phase goes all about drafting the documents, selecting the suppliers, and later on negotiating, doing a fine negotiation of the different contracts so that you can ensure that you're buying the solution. And as a buyer, you protect yourself as much as possible, but also that applies to the seller of the solution. So clean and clear contracts are often good for both sides to finally delimit what are the responsibilities of each of the players. And finally, once that contract has been signed and you found your supplier, there's everything related to the actual construction part, to the solution testing, and to the commissioning, whether it's the factory acceptance test or the later on the site acceptance test that would come just before what we call the project takeover, which would be happening right before you energize your system and start, let's say, using it to generate revenues. Now, what I will do, since we have very limited time, I will try to go to cherry pick some of these four main phases to go a bit more in terms of detail, and that would start with what I would call the feasibility study. So, as I've said before, the feasibility study for it is divided into two main activities. The first one is about the screening of the site itself, where you're planning to put your battery. So, like I've said, so the available surface is very important. One of the elements that have been, let's say, evolving in quite a positive sense is solution formats, which is coming up on the next slide. So solutions have been getting denser and denser, so you can put more, let's say, megawatt hours in a more restricted space, and that has been quite an interesting evolution of the industry with time. The other elements that you would need to analyze in terms of constraints. So as I've said, your proximity to residential or urban areas, how much noise your product is generating, and does it respect the applicable local regulations, and the risk of flooding, of course. So you can't use your battery if it is flooded. So that would one pose a lot of risks, let's say in an electrical sense, but as well jeopardize the viability of your project because it won't be working anymore, and that would be a huge loss when it comes to the expenditure of the project itself. Of course, among the site, there's a part about the accessibility of your site. Do you have any any roads that make this project accessible? That is not just important for you during the construction and operation phases, but also for first responders that would be able to intervene in case there's any kind of incident, especially a fire at this energy storage facility. Therefore, the detailed system design. So the first thing, once you have found the land and you've started assessing the site, initial designs need to be prepared, such as what we call the site layout, which is what you see in the image on the bottom right side. So you try to prepare initial layout of your site to see, one, it would help you design it and see what it would look like, and two, in very different geographies, you also need it for your initial construction permit submission. So you need to have this kind of schematic. The way how, let's say, how either developers in-house can do it, or we as an organization can do it, is to rely on some of the leading solutions in the industry to start forming an initial idea before then refining it during the procurement, let's say the actual supplier selection phase. And once that layout has been developed, there's another subset of let's say drawings that's also required, which is what we call the single line diagram. The single line diagram also gives a more representative and electrical representation of the layout, where you get more details about the sizing and disposition of different equipment, such as cabling, electrical protection, as well as, in some cases, the exact network communication structure that could be required by either distribution or transmission system operators to actually better assess the connection permit. Now, I've talked about the feasibility study. So now there's about the permitting. So when it comes to permitting, it's so the graphs, let's say this the slide says it all. So you need to prepare different permits. So the first one, a very important one, is the building permit. So that's why you would need your layout and single line diagram, as I've said. And in different geographies, whether it's in France, for example, you would need to also prepare initial fire risk report, which is actually targeted by local fire brigades in order to better understand the risks that the battery could pose, and then also issue recommendations that would be needed to ensure that your project obtains this building permit from the local authority. Then, of course, you have the grid connection authorization, where you would also need to clarify the specifications of your project, as well as the different metering schemes. So that's where, once again, having a layout and having single line diagrams would also be good, so that you can at least have an initial idea of how the system is composed and what kind of equipment is being used, even though that you can it might later on, and would definitely later on, change during the supplier selection. But it's that remains possible when it comes to actually submitting a modificative, let's say, permit to modify your submission and get it verified by the local, let's say, system operator. The land lease, so there's not much to say in here. So you need to ensure that you have secured your land before actually buying the battery and signing the contract. And the environmental one, where you would need to also ensure contact with local authorities to clarify any risks and any potential effects of the battery on its local environment. Um, so we've already talked about the feasibility parts, the permitting part, and now another very important part, which is finding the supplier and signing the contract. So what I've done here is I split the slide in two parts. So I'll be talking about what you should do and what you shouldn't do. Maybe we can start with what you shouldn't do. So what you shouldn't do is you shouldn't be unsure about what you'll be using your battery for. So this goes back to the point about the economical feasibility. So the economical feasibility is a part where you would actually identify the target applications that would help you generate maximum revenues for your batteries. So, on that sense, you're not only knowing what kind of services you'll be tackling, but also having an idea of how your battery would be used. That is very important so that you get uh, on a first level the expected lifetime to ensure feasibility of your project and maximum, let's say, revenues, but also what we, as Arthur said later before, the cycling rate. So that is a very important part in which on which battery suppliers base their offers and as well base the potential sizing of the battery. If you have the expected lifetime of your business case and how many cycles you will be doing by every day, that's at least a very first point of what you should have as information. The second point is about tossing a bottle in the sea. So here was what I'm trying to say is that don't try to let's say send your let's say it's your RFP document to every single supplier in the world. It is better to keep your crowd limited by on a first level selecting tier one or well referenced suppliers that actually offer solutions with enough references and have a good experience with the industry. And the other point is about what I call the allotment strategy. So when it comes to buying an energy storage system, you should need to understand what you're trying to procure. Are you just trying to procure, let's say, the battery container itself, so the DC part? Are you just trying to buy the inverter, the transformer, or 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 even only the engineering part? So all of that is very important so that you can anticipate any potential interfaces with different players, and that you can finally delimit how things should be done. And that point is specifically linked to the first point about in the do section, where you need to once again clarify this exact scope of work and these specific responsibilities, so that everyone is clear on what they are expected to do. And in case of any conflict later on, you still have your own contract that's well redacted, well drafted to delimit that. And usually, we're using what we call a RACI matrix is very important so that you can go into a more granular approach to distinguish between the different parts and what is the responsibility of each of the stakeholders, whether it's the buyer, the battery supplier, the engineering company, or even the local authority slash system operator. What you should also take account of is the local regulations and product certifications. So local regulations, especially when it comes to environmental conditions and fire safety, are very important because they can also affect the viability of your project, especially when it comes to distancing battery storage systems, the selection of specific solutions. All of that would also play a very important part in the technical feasibility. Then there's also the certification part. So it's not only important for fire safety, but also on the insurance and financing part. So many insurance companies are actually tricky when it comes to buying a solution that's not well certified or having fire safety certifications such as UL 9540 certification on the system level. So if your solution doesn't have it, some companies may actually either increase the premium or just not insure the project, let's say once and for all. So these elements are also very important. Uh, there's also what we call, and what I'm saying here, and which actually came before in the poll part, is the cost metrics. So the cost itself is not the only metric. So there are more, let's say, more diverse elements. You have the cost, you have the actual performance of your system, you have the supplier, let's say, references. So it is always recommended to work with a supplier that has references, and that also plays greatly when it comes to financing your project, as working with an unknown supplier may also pose some risks on the financing part. And finally, the warranty and guarantee parts. So you will need to make sure that the system remains operational for the expected lifetime. So having clearly defined product warranties and performance guarantees are very, very important, and especially during this operational phase of your project. So indirectly, while I'm talking about the don't phase, I covered most of the do ones. And as just to go briefly, since I see that we're almost out of time. So on the do part, the performance check metrics. So the most important one that shouldn't be forgotten about the availability of your system, the round trip efficiency, and the usable capacity. So the round trip efficiency and usable capacity must always be assessed at the point of connection. So you should, because that's what you can actually use, and that's also a very important element that should be noted. Once you define these performance metrics and what you're expecting from your battery supplier, you should also configure adapted penalty rates so that you can say that to your, let's say, battery supplier, if you don't respect these conditions over the lifetime, and since I'm paying you to ensure, let's say, a no add contract, some penalties would apply if you don't respect this obligation. Uh, as for the document itself, and as others said, the document should be quite extensive. In it, you should clarify the specific conditions of your site, whether it's the environmental ones, the targeted interconnection level, as well as the process, how the procurement process should be happening, and what are your hard deadlines, whether it's for the expected commercial operations date, expected takeover date. And finally, one very important point is about the promotion of transparency throughout your process. So whether it's a private or a public procurement exercise, it is very important to ensure that all of your communications remain transparent across all of the bidders, and that not only ensures that no one is getting, let's say, sidelined, but also would help support any healthy competitions amongst bidders, and will very often end up being, let's say, having a very positive impact for the buyer himself in terms of contractual negotiations and cost negotiations as well. So I see clear that we're out of time, but let's say this slide only goes back to what I've said before. So with time, solutions have been getting denser and denser. So today, at least from this year and later on, we have seen that solutions not only went down into prices in terms of prices, but we are also converging into solutions that have a 20-foot container format. And this kind of format is quite positive because it allows to simplify the on-site cabling works, but also offers a higher density per unit. Besides that, we've also seen solutions that are what you call the EC level enclosures, in which you're not only finding, let's say, the DC part, but you also have, let's say, power conversion systems, so inverters already pre-included. So in that sense, you are also optimizing, in addition to the energy density part, you're also optimizing the footprint of your project because the PCS element is already included in the container. So for your further documentation, you can just take out this table where I'm actually trying to compare the two still existing variants of solutions, but to showcase the advantages and disadvantages of each one of them. Um, so that you can better understand. And the very important note here is that even though this is a tendency, so there's no, let's say, it's the decision itself is neither black or white. So there's always a gray zone where you will need to adapt depending on your local restrictions and on the specific project size plus a targeted application before choosing the exact solution form. Uh, so finally, so this is the allotment strategy. So I won't go into the entire table, but the thing to say here is that whenever you're trying, as I've said before, it is very important to define the target of your exercise, and to be very clear on what you're trying to buy, to better define who is your target audience during the procurement exercise. So the first one is more about so what we call the turnkey EPC contract. So in a turnkey EPC contract, you're just emitting a procurement process in which you would say that, okay, I will need to buy a complete package from a supplier that would need to do the provision of the energy source system, do the entire on-site engineering, grid connection, and maintenance work over the lifetime. So in this section, you would have lower number of negotiations because you would get your offers, you would review them, and have another round to get your best and final offers. The other one would be more about having a split where you try to procure the battery storage system separately. So you buy the equipment, but you would also need another player called the balance of plant contractor that would need to come on site, do the installation, all of the civil and electrical works on site, and procure the high voltage transformer if your project requires a high voltage transformer. So in there, you would have two parallel negotiation works to happen. In that case, so you have more interfacing work to do, but some potential savings can be done if you're trying to negotiate these, let's say, the equipment and the works separately. And finally, let's say the most, let's say, extensive one is if you need to buy a high voltage transformer, is to procure this transformer separately so that you have one integrator, one balance of plant contractor, and one high voltage transformer. So over there, there's also even more interface works and more negotiations to be done. But potentially, the advantage in here is not only the potential savings, but more specifically the potential lead times that would help you to slightly reduce the lead time, so for you to obtain this high voltage transformer, which is the trickiest element today, since there is quite a crunch when it comes to the actual offer and manufacturing of these transformers. So on that note, I'd rather stop to get your questions. Sorry for taking too long. So happy to go to that with Arthur, and don't hesitate to reach out on my contact info that you can see on this slide.
Thank you, Naim, for this really interesting presentation. It triggered a lot of questions, so it was definitely interesting. So thank you. Given the time, we won't have time to answer all the questions, but we'll cover a few, and after we'll come back to you by emails if the question was not answered. Maybe we have a few questions about the Cosmos app. So maybe you could say a few words about it. How can we find it, and how does it work?
Yeah. So for the Cosmos app, what I would say is just reach out to us. I'll be happy to give you more info. The tool itself would be based on an internet accessible platform. So we will create you an account and you can access it to do your simulations and use our forecasting data to simulate different storage sizing and get this revenue stack for specific geography and specific project application.
Thank you. Another question for you from Thomas. Hi, Naim. What is the average size, mean max range of projects which you manage with your tools? Are you actually involved in permitting? Sorry, go ahead.
Sorry. So when it comes to the project that we have managed with our tools, we went all the way to. So I don't have any specific value in mind, but right now I'm leading the procurement of different projects, with each one of them being around 300 megawatts and 2 to 4 hours. So that is let's say the average volume of price project that we see in Germany, let's say in Central Europe specifically. So we can go all the way from 1 megawatt to 600 megawatts, let's say, per project itself. So that covers everything from doing the business model and forecasts and doing the procurement itself. So this procurement, as I've said, we've done big ones in Central Europe as well as in the Middle East.
Thank you. Next question from Vadim. What are absolutely minimum of warranties, I think Clean Horizon will recommend to purchase from ESS integrators?
So when it comes to warranties, so let's say the best case is to ask for warranties that would span over the entire lifetime of your project. So how does it usually happen? Sorry, when it comes to warranties, so you have let's say the by default or the legal warranty that would go up to 5 years for your inverter and transformer. For the batteries, it could go between 3 and 5 years, depending on who's supplying the battery. Then beyond that, let's say beyond that threshold, you can then, depending on who your battery, let's say your solution supplier is, many of them can actually provide a warranty extension over the lifetime. So this one would of course be, let's say, would not be for free. So you need to pay for it, and it's usually based on how much risk taking is can be covered by the supplier, by the integrator, let's say himself, and the kind of negotiations that it had with its own suppliers. So that usually happens as what we call a backstop guarantee with the transformer supplier, and then the inverter supplier, as well as the battery one. And now, if we're talking about performance, so performance ones are usually what we call the performance guarantees. So there's this nuance, slight nuance between warranties and guarantees. So warranty is the equipment one, and the performance guarantee is more how the system is performing. So once again, this one should, so if you're ready to pay for it, it should be covering the entire lifetime, so that you are at least sure to stick to your expected, let's say, revenue streams. And some, however, it is not mandatory. Some players are actually more risk taking. I'm talking about the developers, where they say, okay, I expect to make most of my revenues over the first 10 years of the 20-year lifetime of the project. Over the rest of this period, I might just either just get rid of these performance warranties, or tweak them down in terms of what is actually required, so that I can save up some money and just live with that. So it's really depending on how your business model is being built, and what is the actual cost of these guarantees and warranties.
Thank you, Naim. We have also a question here about how much cost do the AC balance of system, I guess, add to the BSS pack?
Yeah. So for the BOP itself, so I can't really give you a specific value, because there's also a lot of parameters that are affecting that. So there's the project sizing. So of course, if your project is big or small, that would change. Now, how it would also happen is that, once again, there's the scope. So if you're only talking about in terms of BOP, about going from everything from, let's say, doing the engineering, supplying all of the equipment and installation, it could, in terms of cost, cover everything between, I don't know, I would say between 20 to 35% of the overall project cost. But once again, I'm just trying to say that this value should be, let's say, shouldn't be taken as a reference, because it's always dependent on your sizing of the battery, and what you're actually asking the BOP to do.
Okay. Maybe we'll take two more questions. Here, can you recommend the manufacturer of NMC batteries if you use this type in your project?
Hmm. So as I've said, so as of today, let's say, I would say 90 to 95% of stationary storage projects have been shifting to the LFP chemistry, because it has been, let's say, less expensive, and increasing in terms of density with time. However, let's say, and here I need to say that I'm not sponsored by any of the suppliers, but when it comes to NMC, some of the biggest suppliers of stationary storage in NMC are South Korean ones, like LG Energy Solution, or Samsung SDI.
Thank you. Maybe a final question. How Clean Horizon suggests to assess the augmentation cost if the price trajectory in 5 or even 10 years is not clear?
Yes. So for the augmentation, so that's also a very tricky point. So depending on what kind of revenues you're expecting. So if you have signed a contract that's based more on a long-term PPA, so you're getting a specific output for a constant as well, constant activation or use of your battery, the augmentation can be something to be considered. Now, how does this augmentation happen is very important. So some players, especially big suppliers, would opt for initial oversigning of your system in order to ensure that with time you don't have any let's say compliance issues between different product generations. Smaller suppliers would rather propose periodic augmentations with time. So this kind of periodic augmentations would certainly allow you to benefit from lower battery costs, but you would also be having every single time one-shot costs linked to the intervention on site, stopping your project to do this augmentation, as well as logistic ones. So there's no, let's say, common answer for that. This is also even more consistent when it comes to using a merchant project. So for a merchant project, it is also very interesting to consider. So when you consider your applications and what the battery is supposed to do, that also gives you an understanding whether an augmentation would actually be needed, let's say 5 or 10 years later on. Because if you happen to generate maximum revenues over the first 5 or 10 years with the product and recover your investment, that is fine. And the very important thing to note is that most, let's say, already have commercialized LFP solutions ensure a 20-year lifetime with a 1 cycle per day. If you do 1.5 cycles per day, you can go all the way up between 15 and 17 years, depending on who is supplying your battery, which is quite good, honestly. And once again, you would need to refine your business model and your revenue stack to get a better answer on whether that is actually needed or not.
Okay, thank you, Naim. So there are many questions that we didn't answer, but I suggest you reach out to both Naim and I offline, or also we can come back to you once we'll have the list of questions. In any case, thanks a lot for your participation and for sharing a lot of questions. It's quite appreciated. And our next webinar will be announced will be available in 2 or 3 weeks. Thank you, Naim.
Thank you. Have a good rest of the day. Goodbye.
Take care. Bye.
Visit Sinovoltaics.com to learn more.